Okay, so this video is for the 2015 question, question 2. Just double checking that, I'm pretty sure. Yep, question 2, 2015. All right, it's the one with the picture at the top. This one with the picture at the top. All right, and in question 2C, it says, because the dehydration reaction, the dehydration of the ethanol, so pulling the water out of the ethanol to the ethene, so it's pulling water out of the ethanol and giving you ethene. It's pulling basically two hydrogens and the oxygen out of the ethanol. So 1, 2 out of the ethanol, and you're left with C2H4. See that? So that's a dehydration. You're pulling out 1, 2 hydrogens and the oxygen, and you're being left with ethene. So they're calling that a dehydration. So because the dehydration reaction is not observed to occur at 298, 273 plus 25 degrees Celsius, so 298, so standard conditions. If the student claims that so it's not observed at 298 degrees Kelvin. The student claims that the reaction has an equilibrium constant less than 1 at 298. All right, so a K, an equilibrium constant, K, less than 298. So let's remember, first of all, that K is equal to the concentration of the products over the concentration of the reactants. So right away, the student is saying that the reason that this is happening is because this is less than 1, which is going to drive, so at equilibrium, the reaction would be more to the left, more toward the products. And the student is saying that this ratio would be less than 1. All right, so the question is, justify your answer using a calculation of delta G. All right. So first, they give us in the problem, see, they give us the delta H at 298, and they give us the delta S at 298, and we have the temperature. So first of all, if you didn't know anything at all, you could calculate your delta G using those 3 things, and you could come up with positive 795. And you could stop there and say delta G is positive, and so therefore it's a non-spontaneous reaction. That would actually get you 1 point out of this problem. But that's not completely the answer. And so, but that would get you 1 point, but that's not the whole answer. So the next point would come from comparing that, because you didn't actually get to the equilibrium here, but you calculated delta G, that gets you 1 point. Now, delta G is positive. You could say, okay, it's non-spontaneous, but that didn't help you with the K. So like I said, do anything. The phrase is, if you can't do something, do anything. You don't know where the points are going to come from. So the next thing is we have this formula, and this is the formula that Gracie asked about, that I said, I want to be sure that I know about the formula before I speak. Here is the formula. This formula is in your packet. Notice the ln of k, the natural log of k. Now this r is not the r that we know, so you're not really going to be asked to plug in. This is a what does this reaction tell you formula. Now remember, K is products over reactants. All right, and so what we're trying to evaluate is whether K is greater than 1, less than 1, or equal to 1. So this is all about, what is this going to give us? Is this going to give us a positive number, a negative number, or 0? So here's the thing about logarithms, natural logs. They are predictable. When the natural log is of a number that's greater than 1, less than 1, so k would be less than 1, then the number is negative. Okay? Then the number is negative. Now, so if this k is less than 1, then this number would be negative. A negative times a negative is a positive. So delta G would be positive. Yes, delta G is positive. This confirms that the student was correct, that K is less than 1. This confirms that. This is a non-spontaneous reaction where the K is less than 1. The ln of K is negative. A negative times a negative is a positive. Therefore, delta G would be positive, and in fact, it is. What if K was greater than 1? If K was greater than 1, then the ln of K would be positive. We would have a positive times a negative, which would tell us that delta G is in fact negative. That does not go with the answer that we found for delta G, so the student would be incorrect. K would actually be greater than 1. What if K was equal to 1? Then the ln of K would be equal to 0. And if the ln of K is equal to 0, that would be 0 times, it doesn't matter, delta G would be equal to 0. The reaction would be at equilibrium. So then again, the student would be wrong. All right? And so this is under standard conditions, which is 298 Kelvin. So that would mean that the student would be wrong. All right, and so this is how this reaction is used. I think here it's important to remember that the ln of K is going to be negative. If the K is less than 1, the ln of K will be positive if the K is more than 1, and the ln of K will be 0 if K is equal to 1. Again, this reaction is in your packet, and so they're comparing the two. You don't have to calculate, they're comparing the two. All right? Hope that explains it. Also, what I did assign you over the weekend was the AP video exactly on this problem, and then 3 problems that the AP, the 3 multiple choice and a free response that the AP College Board applies to this problem.